Global warming is one of the biggest threats to our living planet. It occurs as a result of the depletion of the ozone layer and the greenhouse effect. To understand how this phenomenon occurs, we see here how carbon dioxide gas rises in the atmosphere, causing the temperature of Earth to increase. Waste gases from industry and carbon dioxide released by vehicles are the main causes of global warming. The sun's enormous energy heats the Earth's surface and the atmosphere. Global warming will result in the Earth's ice caps melting and a rise in sea levels. Water has multiple uses in the environment. Water from reservoirs and rivers is pumped into a water purification plant. Water purification involves several steps, such as mixing, whereby water is mixed with various chemicals. In the flocculator, soil and other waste materials form clumps. After this, sedimentation takes place in sedimentation tanks, where clumps of waste products sink to the bottom of the tank and pure water is drained. In the chlorination process, water is chlorinated to inactivate disease-causing viruses and bacteria. Finally, the purified water is stored and pumped through pipes to houses, where it can be used for drinking. Water used for agriculture can be taken from rivers, reservoirs, or wells. Electric power is generated by water stored in dams. Hydropower generation is a very economical and clean source for generating electricity. To protect the environment, the harmful effects of pollutants in the atmosphere have to be reduced. Polluting car exhaust emissions can be reduced using a catalytic converter. A catalytic converter consists of a stainless steel chamber with a ceramic structure. Platinum, palladium, and rhodium are used as catalysts. Using a catalytic converter, harmful gases like carbon monoxide, hydrocarbons, and nitrogen oxides are converted into harmless gases: carbon dioxide, nitrogen, oxygen, and water. In the visuals, we see structures of some organic compounds. Methane is the first member of alkanes. Alkanes are saturated hydrocarbons. It has a tetrahedral structure. Ethene is the first member of alkenes. Alkenes are unsaturated hydrocarbons. They are differentiated by their double bond. Cracking is the process of breaking down larger molecules into smaller molecules by heating at high temperatures. Look at decane as it is cracked into ethane, propene, and pentane. Reforming is the process of converting straight-chained molecules into branched molecules using heat, pressure, and a catalyst. In the visual, the straight-chained octane is being converted into 2,2,3-trimethylpentane. Paper chromatography involves the distribution of substances in two different phases based on their mobility. Usually, a good quality filter paper is the stationary phase, and a solvent is the mobile phase. Draw a line on the chromatography paper. Apply the test sample as a small spot on the line and dip the lowest part of the paper in a dish of solvent. Chromatography works on the principle that different compounds have different rates of solubility and absorption. Chromatography is also used to separate mixtures of colorless compounds. The solvent rises up the chromatography paper by capillary action. When the solvent reaches the spot, the mixture of colored chemicals dissolves, forming a solution of different solutes in the solvent. Based on their size, molecules of different substances separate and move to different heights on the paper. The final developed paper is called a chromatogram. Petrol, a hydrocarbon, is used as fuel in car engines. On combustion, petrol forms carbon dioxide and water, and heat energy is released. This is an exothermic reaction. The gas in the cylinder expands due to the heat energy. The piston's backward movement expels the burnt hydrocarbons to pass through the exhaust. In the blast furnace, iron is extracted from iron ore, hematite. In the preheating furnace, iron ore is mixed with coke and limestone and carried to the charging tower by the conveyor belt. Now let us look at the cross-section of the blast furnace. The cone or sealing valve arrangement is lowered to allow charge into the furnace. When closed, it prevents waste gases from escaping. The walls of the furnace are made of heat-resistant magnesium oxide bricks. Hot air inlet pipes are called tuyères. Molten iron flows out through the outlet at the base. Slag, calcium silicate, which has a lower density, floats out from the outlet above. In the lower section, carbon burns in hot air and forms carbon dioxide. The temperature in this section is the highest, at 1900 degrees Celsius. In the middle section, limestone decomposes to calcium oxide and carbon dioxide, and the temperature drops to about 1000 degrees Celsius. Calcium oxide acts as a flux and forms slag. In the upper section, iron ore is reduced by carbon monoxide gas and forms molten iron or pig iron. The temperature in this section is around 600 degrees Celsius. Slag is used for many purposes, including fertilizers, additives to cement, and also for road laying. Here we see a refractory kiln used to manufacture quicklime, calcium oxide from calcium carbonate, commercially known as limestone. The reaction takes place at high temperatures of above 900 degrees Celsius. To avoid a reverse reaction, the carbon dioxide produced is continuously removed. Here is the cement factory. Cement is manufactured from lime and clay. The first processing step is grinding and drying of raw materials. The granules are fed into a rotary kiln and heated to 1450 degrees Celsius. Carbon dioxide gas is released and the cement sets into a hard mass called clinker. Finally, the clinker is mixed with gypsum and other secondary constituents, ground into powder and packed into sacks. During an exothermic reaction, heat is released. When sodium hydroxide is added and mixed to water, the temperature of the mixture increases. As a result of this, the enthalpy of the reaction, which is the amount of heat released by 1 mole of the substance, is shown to be negative. A redox reaction is the basis for an electrolytic cell. A salt bridge is used to transport the ions. Inert platinum rods connected to a low-voltage lamp are used as electrodes. As the reaction proceeds, the current flows through the circuit and the bulb glows. Simple distillation is a process by which a mixture containing 2 or more liquids can be separated based on the difference in their boiling points. In a galvanic cell, chemical energy is converted into electrical energy. A zinc rod is used as the anode, and the copper rod is used as the cathode, and copper sulfate solution as electrolyte. Zinc is oxidized and copper is reduced. The potential developed in this cell is 1.1 volts. Please note the reaction. Zinc equals zinc 2+ and 2 electrodes. Copper 2+ and 2 electrodes becomes copper. The hydrogen fuel cell works as a battery. The advantages of fuel cells are that they never discharge or pollute the atmosphere. Electrodes used are porous carbon impregnated with platinum, silver, or cobalt-2 oxide. A concentrated aqueous solution of sodium hydroxide is used as an electrolyte. Please note the reactions at the anode, at the cathode, and the net reaction. A button cell is a miniature cell which is frequently used to power items such as watches and hearing aids. The anode used is zinc, and silver oxide is used as a cathode. Moist sodium or potassium hydroxide is used as an electrolyte. Please note the reaction at the anode, the reaction at the cathode, and the net reaction. Hydrochloric acid is electrolyzed using platinum electrodes. Greenish-yellow chlorine gas is liberated at the anode, and colorless hydrogen gas is liberated at the cathode. Please note the reactions. 2-chloride ion is released into Cl2 and 2 electrons. 2H plus and 2 electrons equals H2. Brine is a solution of sodium chloride. Electrolysis of brine occurs in a membrane cell where the ion exchange membrane separates the anode and cathode compartments. Chlorine gas is released at the anode, and the sodium ions migrate to the cathode compartment. Hydrogen gas, saturated with water, exits from the cathodic compartment. Here we see a nuclear power plant. Nuclear power is an efficient source of energy production. A nuclear reactor is used to generate energy in the form of heat through nuclear fission. A nuclear reactor consists of fuel rods, control rods, a moderator, and coolant. Here we clearly see the different parts of a nuclear reactor. This is the reactor in which nuclear fission takes place. When a neutron bombards the radioactive isotope of uranium-235, it liberates neutrons. These neutrons in turn bombard other isotopes of uranium. The reaction continues as a chain reaction with the release of enormous amounts of heat energy. In the steam generator, heat energy creates superheated steam to run the turbines. The turbines generate electricity, which is used for domestic and industrial purposes.